So earlier we solved quadratic equations that needed the quadratic formula. This time we're going to look at something similar, but there's going to be something different about our answers. So let's start with x squared plus 5 equals 1. Now notice this is a great problem to use the square root property on because all we have is an x squared term and numbers. In fact, we're going to subtract the 5 over to both sides and we get x squared equals minus 4. Now when I use the square root property, I'm going to get x equals plus or minus the square root of minus 4. Well, the square root of minus 4 is 2i. The negative becomes that I on the outside, and I get my two answers still, but now they're imaginary. They're not real anymore because we're taking the square root of a negative number. Now the other type of problem we could see, suppose we have 4y squared plus 4y plus 5 equals 0. And it doesn't look like I'm going to be able to factor this. 4 times 5 is 20, and I don't see factors of 20 that add up to positive 4 very well, since they both have to be positive. So it's not going to factor. So let's just go straight to the quadratic formula. Y equals minus 4 plus or minus the square root of that 4 squared minus 4 times 5 all over 2 times 4. That's minus 4 plus or minus 16 minus 80 over 8. 16 minus 80 is 64, so we get minus 4 plus or minus the square root of minus 64 over 8, since the 80 is bigger. So minus 4 plus or minus the square root of 8i all over 8. So this becomes, if we leave it the way it is, the 8 doesn't go into the 4 fully, but the 4 does go into the 8. So we do a minus 1 plus or minus 2i over 2. And our answer is, our solution set is minus 1 minus 2i all over 2 and minus 1 plus 2i all over 2. And we can leave it like this, or if we wanted to, we could write this as minus 1/2 minus I and minus 1/2 plus I. This would be in more true complex number form. This is one that we accept at this point as an easier way of writing our fractions.